Hello Internet. So here I have my demo set up. You can see the various 7-segment displays. I have 8 of them so that I can show 32-bit addresses. Here you can see maybe, I hope with the camera, that it is showing 2000. That's the address at which the CPU is going to read the first instruction, but the CPU is stopped. The only thing that is running, so to speak, at the moment is the VGA display, and I wrote with the debug tool I created an image to my frame buffer address. And you can also see some things here. For instance, on the 7-segment display, I have some buttons connected to the FPGA, which these are the arcade buttons to select and escape to the menu. And you can see that they work because on the 7-segment display, the dots are used to show the state of these buttons. So for instance, if I press the first button, one of the dots here turns on, and this is read by the CPU, which is instantiated inside of the FPGA. So in software, I will read the state of these buttons and the state of this joystick. So what I would usually do first is that I have here an utility on this computer, and what I do is that I have a debug utility, and through the serial ports, through this USB cable, I write the codes, the binary codes for the demo that I'll be running on the CPU inside the FPGA. And you can see that at the moment this counter is stopped, but when I start writing the code like this, you see that it is changing, decrementing. This is to reflect that it is loading the code and data for the various segments of my ELF binary file. I'm loading. This is the code for my own ports of the Classic Empire game for the FPGA. I took the codes and did some changes so that it would write to this frame buffer the image, and it would get input from the joystick and the buttons and output the audio to the speaker here. And once this finishes writing, this is the largest segment which has the images and sounds files. It is just about to finish writing these segments. Once it finishes like this, it will go back to showing 2000, which is the address of the first instruction. And then here in my debug utility, I can run a command which says to the FPGA, okay, activate the CPU, let it run. And when I do that, the code starts executing. It clears out the frame buffer, prints out the splash screen, and I get here a menu to choose between human versus computer or computer versus computer. So for instance, I can toggle the option here with the joystick, which is in reverse. Wait, it is in reverse. I chose computer versus computer, and I can change it now because I disconnected my joystick. So let's leave it in computer versus computer. I select it, and the computer starts playing the game. Here you have your initial city. A fighter plane is going around exploring the map. You have here the output that would get the textual output of the game, but also I have the serial debug output here on the computer, which I can open it in PuTTY. So if, for instance, I do write ln in my code, I can see it here on the computer. At the moment, this window is showing which round of the game I'm currently playing, which is also shown on the screen, and it shows the name of the sound effects that are played when they are played. So for instance, when a machine gun sound effect is played, here in the serial output I can see machine gun.wave file. So that helps me debug any issues that are here in the game. So you can see the computer start to explore the map, produce different units. You can check it out, Walter Wright's classic Empire game on Windows if you want to know more about the game. This is my own port running inside a RISC-V softcore CPU. So that means I have a hardware description of how a RISC-V architecture CPU would run. I instantiate that CPU inside the FPGA. I integrate all of these I/O components, and then the code for the game runs on that CPU, and it uses all of these I/O to show the game on the screen, get data from the peripherals, show the current address that the CPU is reading as it executes the various instructions. Here right now I don't have the speaker connected, but you'd get the sound effects. And that's it. So thank you. I hope you enjoyed my talk.